Welcome. Our project is on flying shear machine, which we are doing in wire rod production at Usha Martin Limited, Jamshedpur, which we have done by our batch is consisting of Sanmugam Pillai, Sunil Mahato and Wasim Akhter. Our external guide was KC Madhusudan, which is Deputy General Manager of Mechanical Department, and our internal guide is Mr. Kamalakannan, Assistant Professor of Tech University. This is the flow chart which we are using to produce the wire rod in Usha Martin. First, the iron ore is used to make steel. Then steel is converted from many 3 type DRI coke, and these kind of things is converted into bloom and billet, which is the input to the wire rod mill, and finally we get the wire rod as an output. Application of wire rod is which we are using in automobile parts like suspension spring, bearing, connecting rod, piston and crankshaft, etc. etc. This is the flying shear machine which is used to cut the wire rod while it is in a hot metal, and flying shear machine is used to cut the front end and the back end of the wire rod. Definition is this: it is also called as start and stop shear. It is used in wire rod mill to cut the front end and the back end of the wire rod. 3 different shears are installed in a wire rod mill at different locations after the rolling stands. Lever shear is placed first at the stand number 7, rotary shear second at the stand number 13, and continuous shear after the stand number 19. Company is planning to install another shear which is situated, it will be located after the shear stand number 29. It will be used to cut the scrap out of the wire rod so that the manual unskilled manpower can be reduced. Required condition of the working shear will be drive by a DC motor, power will be 40 kilowatt, RPM will be 1100, volt will be 400 volt, amperes will be 113. So this is the basic design which you are seeing. Motor runs the flywheel through a belt, and then flywheel is connected to a clutch plate, and which is further connected to a rotary shear. Principle of our flywheel is simple, as you have seen there. The roll mill stand which is connected through a gearbox, which is connected to a motor which is used to run the rollers. After the rollers there is a HMD which is called as hot metal detector, which detects the presence of the wire rod, which gives as the input to the PLC which is used to run the shear machine. T1 is the accelerating time for the shear to attain its maximum speed and torque. T2 is the time attained for the cutting the material at the maximum torque. The time travel interval T1 and T2 are shorter interval than the time interval Tc. As you have know, after the cutting period got over, the shear entire into the decelerating period, proceeding with the position control mode to park the shear at the park position. This is the speed time characteristic graph which we have seen. Tc is the time taken, initial time taken by the hot metal detector. T1 is the maximum acceleration time. T2 is the time to cut the wire rod, and the last one is deceleration time period. This is the basic diagram, AutoCAD diagram, which is of the rotary shear which we are going to construct. Its center distance of the blade is 610 mm, and the cutting force will be 150 kN. These are the calculation which is going to undergone under the given condition, which is clutch flywheel diameter will be 1020 mm, motor flywheel diameter will be 340 mm. Motor specification, as we have already known, power to be transmitted will be the 40 kilowatt, and the speed driving wheel N1 will be 1100 rpm. Volt as described 400 volt, and ampere will be 113. Calculation which we have done on the basis of data book. With the help of data book which we have calculated, these are the calculated results. Speed of the driven wheel will be N2 367 rpm. Selection of the belt section will be C section. Center distance C, which is 1020 mm. Nominal pitch length L will be 4289.616. Selection of various modification factor will be length correction factor FC, which is 1.08. Service factor FA will be 1.6. Correction factor for arc of contact FD is 0.89. Calculation of the maximum power capacity is 2.035. Cutting shear cycle of a shear, which we have seen that initially the shear blade will be in initial position in stop position, which is accelerated in 44 degrees, and the further is 34 degrees used to cut the wire rod, and after 71 degree response it is again came into the stop position or start position. Both the same position is same. Brake is applied. Alteration which we have done in tool angle is 4 degrees reduction, which you can see in the diagram, which we have changed to 4 degree less. So fixing the distance of HMD from the machine. This is the first aspect of a project, where we have to place the HMD, hot metal detector. So for this we have done some calculation which results in 26, which results have came which to place the HMD. These are the calculation. Angular velocity which we have calculated, omega is 163.398, angular acceleration alpha is 303.3966, time is 4.5385 seconds. In 0.5385 seconds the wire rod will be traveled 26.925 meter, which will be the position of the HMD after taking 40 centimeter away, because we are taking 40 centimeter as a length of cut. For this we are placing HMD at 26.925 plus 40 centimeter away. Now after alteration in the blade of angle 4 degrees, what will be the outcome? Here we go. The outcome will be the reduction in time, which is 0.4896 seconds. Now the distance traveled at 0.48967 with the previous speed is 24.48 meters. Now as we see, with the same speed the distance travel is 24.48 meters. To cover up the distance of 2.445 meters, the line speed should be incremented, and the new speed will be 55.005 meter per second, due to which the production rate can be increased. Alteration done in the blade angle of the shear machine, 4 degrees reduced due to alteration of the blade angle, due to which the acceleration cycle reduced to 40 degrees. Previously it was 44, now it is 40 degrees. Now as your blade reaches cutting position before time, due to which it results in production speed can be increased. Now how we can increase the production speed? Let's see. In 1 minute 4 coils of the wire rod with 50 meter per second. Now in 1 minute with the speed of 55.05 meter per second, 4.4 coils can be made. Hence the production can be increased. Likewise we improve the quality by replacing the manual labor. Installing place of the machine, where we are going to install it. It is a place after 29 stand before the laying head, before making the coil. Laying head is used, which rotate at 3000 rpm to make the coil. Some other achievement which we have achieved in while making our project is saving 2 unskilled manpower, which results in saving of 16,000 rupees per month. Previously 2 bolt cutter is used by the unskilled laborers, which is 12 blades are replaced per year. 1 blade costs 10,000. With the shear blade, its replacement is 4 blade per year. Now you can see clear profit which we have done by this project. Also results in less maintenance and reduction in maintenance cost. Manual cutting was done after the production of wire rod. Automation cut the wire rod during the production. Comparatively, cutting rate is also increased. It was 2 coils per minute. With the shear machine, it is 4.4 coil per minute. Thank you.